my name is Katja Petzold and I'm from the Karolinska Institute in Stockholm, Sweden. My work is about structural dynamics or structural changes of RNA to understand function of RNA especially in medical background. And so this is what I'm also going to talk about in my lecture this week. So I'm going to start with introducing RNA in general, a little bit of the RNA world hypothesis as a side effect, how we study, with what methods we study RNA structure and rigging and jiggling RNAs. And then I'm going to tell you a little bit of what kind of findings we had so far, for example, how viral RNA, for example, of HIV or SARS-CoV-2 develops and is changing its structure to performance function, how RNA and DNA changes in its structure and so on can actually be the cause of evolution. Also how, for example, RNA changes are important, for example, for cancer development. And actually our most recent finding, also something I'm working here on to finalize the work, is how the largest RNA machine, the ribosome, which makes all the proteins, undergoes a lot of different changes to make the proteins. And we have found some of those changes and we understand them now in more detail. And this is also going to be very important for later new drug development. And I'm going to explain why this is the case. And so this is hopefully a new type of antibiotics against, I say, multi-resistant bacteria. So we study RNA because RNA is mostly considered the middleman between DNA as a storage and protein as the action person. But RNA is actually a whole variety of different types of characters. It can store information as in viruses, can process information or carry information in mRNA, for example, the vaccine we had, or make proteins as a catalysator. So it's very variable and it's a lot of RNA, and just in recent years we only started discovering the whole variability of RNA because it's been so long neglected. And now what we specifically study of RNA is actually how it kind of looks in the 3D space, like as a beautiful picture. And when you think about pictures, they're very static and they look beautiful, but they don't tell you everything. So we go one step further. We look at how RNA moves, so we basically make RNA movies. And therefore this allows us to understand really how the RNA actually performs its function.